Hey there, welcome to the Stormwater World podcast. After 10 years in the stormwater industry, I feel like I've only scratched the surface of all there is to learn. I believe there are a lot of people just like me who are curious, but we're all just so busy. So I'm going to ask the questions so we can get the answers together. My name is Ty Garman, and I'm your host. Join me as we learn about what is happening in the stormwater world. Hey, everybody, welcome back to this episode of the Stormwater World podcast. Pretty excited about this episode. I am a true on tech geek, personal life and professional life. So I'm pretty excited about our guest today. With us today is Dr. Christopher Foley. He is the CEO and president and co-founder of P4 Infrastructure. He's a licensed professional civil engineer with nearly 40 years of experience in the civil infrastructure systems. His experience spans engineering, design, fabrication, teaching, and research. But before you stop listening to this podcast because you think, oh my gosh, so technical, so much technical information, let me give you a little bit of frame here. So what's happening out here in our stormwater world is that everybody thinks that their BMPs are doing one thing. And in my opinion, even though I live on the outskirts and I live in the compliance software industry, after 10 years of just listening to everybody else, we test these stormwater quality devices to death. And then we put them in the ground and we tell everybody, hey, this is what they're going to do. And I don't think they always do that. And I think there's a lot of other people that agree. And I think Dr. Foley is going to show us that it is absolutely true, that what you think is happening is not happening. So you got to ask yourself, what if? What if you could actually know in place after it's in the ground what your stormwater quality devices are doing and have that data in real time so that you can show and prove that these tax dollars that we're spending are going to the forces of good and actually improving our water quality. So that I probably just set you up real big and high, Dr. Foley, but I'm happy to have you here and welcome to the pod, sir.
Well, thank you, Ty. I appreciate
it. So let's go backwards before we go forward. So P4 Infrastructure that you founded by three, let me see if I look at my notes here, it's founded by three licensed professional civil engineers with doctoral degrees. So combined, you guys have over 70 years of experience in the civil engineering world. And so what happened? Why? Was it? Was it based on what I said? Like we got to prove this. This thing's not working right, or what? When did P4 start, and what made you want to do it?
It's a great question. It has been not a long story, but certainly an interesting one. So I had been a faculty member at Marquette University in Milwaukee, Wisconsin for 22 years. And as part of my duties as a faculty member, and then as I was department chair, we were looking at ways to increase both the breadth and the depth and the I guess you would say, the quality of our civil engineering programs. And I created a course called Introduction to Infrastructure. And that course was all areas of civil infrastructure systems, from environmental engineering to structural engineering and everything in between. And what we did is we tried to illustrate what and how you finance civil engineering systems as a part of that course. So it was maybe a 2-week experience. Right. And in that 2-week experience, I came across the concept of a public-private partnership and thought to myself, okay, if a public entity, a municipality, is going to want to have infrastructure provided by a private company, how do they do that? Well, that company might actually design, build, finance, operate, and maintain that infrastructure system for the municipality for a period of time called a concession period. And once that concession period is over, that infrastructure is given back to the owner to do what they want with it. They can find another person to operate and maintain, or they can rebuild, or they can operate and maintain themselves. But what is required is what condition is that infrastructure in? That's data. Another one is how well is it performing after it's been constructed? That's data. So in my mind, a big data application came out and jumped out. And as I started thinking more and more about public-private partnerships and the use of data and sensor systems, I thought it'd be kind of cool to have a public-private partnership in civil infrastructure And it may be in stormwater infrastructure systems. It may be in other areas that we deal in structural engineering, traffic signs and signals. But nonetheless, it was a data centric endeavor. And that's what
Gotcha.
we did. And that's what I thought about. And I said, well, how do we do that? I can't do it at the university at the time scale I would like to do. So I left and started P4 with Nick
Okay.
Horniak and Joe Diekfus. So we are data companies and we try to set ourselves up to become the data source of truth for performance, operation, and maintenance data of stormwater infrastructure systems now. So we turn a stormwater infrastructure component into actionable data through sensor systems that we design, fabricate, and in the end also help maintain.
Gotcha. Okay. So I'm going to dumb that down for myself, and make sure that I understand it. So, like, I think of data, big data. I think a lot of people, when we think of big data, Google, Facebook, Amazon, big data, right? And so, with big data comes big power, and should come big responsibility. But we're not. That's a whole different podcast. So, big data to me. So, like, what? So, if we apply that to stormwater, so if my phone is the central point of where I'm getting all these ads and how I'm getting targeted and all these things are happening to me because of big data and the things that I'm doing. So we apply that to stormwater. You're taking and you're obviously somehow putting a device or something in an existing or during the first build of a structure, and then you're pulling that data out across multiple structures at the same time, multiple geographic. And so not only do you have real-time data on my particular device, you've got big data. So you can
And
you
that's
can
exactly
create
it.
conclusions based on real data, not a test in a lab that are good. Hey,
Yeah.
they serve their purpose. I'm not distracting. I'm just saying there's a difference for me. Uh, you know, well, okay, so it's awesome. Like this, my wife's gonna love this pod because she is a civil engineer
Nice.
by trade. She's with over 20 years of experience, drainage engineer. And so, but there's a difference between taking the test and then going out in the field. And
You hit it exactly on the
I
head.
think
And
that's
that's
what we're
how we've
talking, right? That's what we're talking about for
100%.
everybody.
In fact, when I gave the big picture of what P4's founding was, and P4 is products for public-private partnerships, but we're
Okay.
focusing
Oh,
now
I'm
on
not. I see. That shows
stormwater.
you. All right. That shows you how
Yeah.
dumb I
So
am. I
now
didn't even
in the
catch that. All right.
stormwater,
P4. Got
in
it.
stormwater, you hit it exactly. It's if you have the behavioral and performance data of a piece of infrastructure, and we operate in all areas of stormwater management, a surface pond, a below ground pond, on structure detention, the roofs of building systems, biofiltration systems, permeable pavement systems, of course, as well. All of those, if instrumented, become data points that give you a holistic measure of how a watershed behaves. So not only is it your local
Okay.
performance data for your, call it, surface pond, but it's also how does that surface pond collect water according to your models that you've developed? And then how is that pond interacting with a permeable pavement surface in a nearby area still tied to the foundation watershed? And that data now becomes a much better way of understanding of how the whole system performs. Not only your data and your infrastructure, but also everybody else's data and their infrastructure collectively serving as the stormwater management tool for the community or the region, if you will. And we have our devices from California to New York, to Maryland, to Florida, to Michigan, to Illinois, and to Wisconsin. So it's everywhere, and we're developing a regional and national presence with this stormwater management data. And that's really where we're trying to head.
Okay. So right. So if you so good, that's amazing because if I've got a model, I've got assumptions. And with what you're saying, the more assumptions I can remove, the more accurate my model becomes, and then the better I can build within that community and
Thousand percent.
and protect
And I'm a
people
structural
from.
engineer by trade, which is really weird. Your
Gotcha.
wife will understand that I'm one of those structures people, and we're on the other edge of the coin. But with that, I think of what we have as this data set as what in my world used to be called finite element analysis. And you might say, well, what is that? Well, it's just a
Okay.
mathematical way of taking discrete pieces of information and stitching them together into a holistic view of a bigger system. So the more you know about what's happening in the small component systems, the more you know about what's happening in the big system. And that's really where we're headed is the models exactly. You have engineering judgment that creates models that are is the best models you can create. All of these models have been void of stormwater data that was measured in the field in these systems.
Gotcha.
As you start including that data, your models get better. And as your models get better, your fiscal awareness gets better, and you start spending money in a better way. And you spend more when you need to rather than just because. And that's where we want to head. We want to know why we're spending the amount of money we are, and we want to target our spending in directions that are the most bang for the buck.
I gotcha. I gotcha. So, what would be like? How would you want to? Do you have some specific examples that you could like walk us through, or that you would want to
Yeah,
share of say, maybe I don't want to say. I think I think saying like a successful example is ridiculous because I mean just having the data is a success, right? Like, but I think there's if you could provide like a real world example, I think it would just help to paint that picture for maybe
yeah.
the
I mean, there's
even like me, I've been around for a while, and I think it still kind of gets a little, anytime you start talking about modeling and it gets a little ethereal versus like really when the rubber meets the road. Do you have some examples you would like to share?
Yeah. Let's. I got a couple. I could do short ones. One is in an area that you're familiar with the work that we've been doing. Really started with pave drain in the permeable pavement arena.
Okay.
Permeable pavement is a very, very powerful tool, my opinion, my engineering opinion, in an urban setting, because you've got a lot of paved surfaces that really need, if they can be, turned into a permeable surface and allow stormwater, instead of conveying over the top, to go down through the surface into storage treatment galleries and discharge galleries below. So what we found, and we did some instrumentation here in Wisconsin with the city of Cudahy, and we created sensor installations in 3 alleys that were permeable. And the city of Cudahy really didn't, they knew how these things would perform, and they had a good gut feel that their stormwater was going to go into the storage galleries through the pavement surface very effectively and be discharged. But what they didn't know was that the ground would actually allow infiltration of the stormwater from the gallery, meaning the water
Okay.
wasn't going into the filter mechanism and exiting. It was going into the filter mechanism and then returning to the ground rather than the surface water. And there are different ways that you can credit pollution removal in states. So if you return the water to the ground through a filter, there is a pollution removal from the surface body of water that is really 100%. If you're sending it through the filter and then into the surface body of water, all you get is credit for the filtering, and it's not 100%. It's much better than piping it or conveying it directly to the surface body, but the system behaves best when you can infiltrate the water and into the
Makes
ground,
sense.
that is.
Okay.
And Cudahy had no idea that this was going on. So we put sensors in, and we noticed that the water levels below the pavement were never rising. In other words, there was never water accumulating in the
Okay.
gallery. So we
Gotcha.
told them, let's shut off your discharges. And they were like, oh, you cannot shut off the discharges. No, 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 the
Yeah,
world's
we're
going to
gonna,
end.
cause yeah, we're gonna flood everything. Everything's gonna
Yeah,
flood. We're all gonna
everything's going to
die.
flood.
Yeah,
We're
yeah.
done.
I'm with you.
So, so we said, look, we've had
It's
sensors in
for,
the
but
ground.
it's for science. It's for
Yeah,
science.
yeah. Let's flood the neighbor. Who cares? It's a
Yeah,
good
I mean
cause.
it's good. Just one time, just one time.
Yeah.
Gotcha, gotcha.
So we plugged the drainage from the galleries. In other words, we shut it off. And
Kids, don't try
lo
this
and
at home.
yeah, don't try it at home unless you've got your sensors in the ground.
Yes.
So we had that documentation and that evidence to make a different decision and make a different model. And that model was one of infiltration. So as we shut off those under drains, as they're called, or the discharges from the storage gallery, lo and behold, the water was accumulating and the water was going into the ground. So those 3 alleys were built with a certain credit associated with them. I'm just going to pick a round number. They were 30% effective at removing phosphorus or suspended phosphorus, kind of a
Okay.
technical term. However, when the water is filtered and returned to the ground from the surface body water point of view, that's 100% removal of total phosphorus or suspended
Okay.
phosphorus in the water. When you go from 30 to 100%, that's a significant improvement. If you did that with all the alleys in the city of Cudahy, they might not have to build any more ponds. So now your
Hmm.
urban environment can have developable land. You don't have to worry about the fencing that's required and the water storage that is present in a surface lake that you just created. So it's a different tool that has an appropriate position in stormwater management that you may not have considered in the past because your models told you they were behaving differently. The minute your models are more close with reality, you have more tools at your disposal to devote to stormwater management. And when all those tools have a good level of play with each other, everything becomes more economical. And in the end, clean surface water is what you get, and you get it faster because the spending that you have is more directed and more intelligent.
Wow. There's a lot. That's a lot to unpack. So just by that one example, we've saved. So we're in more compliance. We're in a high level of compliance. The stormwater, the quality, water quality, which goal number, it should be goal number one, goal number three, whatever you want to go. Like that again, that different podcast. The stormwater quality is a higher level of improvement, higher level of compliance, and you're backdooring it all the way back around to less detention pond creation, which is more developable area, which creates a higher level of tax base for that particular municipality. And then everybody's winning across the board, basically, because more places for businesses, homes, and more tax revenue for that city. And that city can therefore turn around and do good things with that tax money. And,
And it
you know,
really,
the
and
way
I'll
it's,
be
yeah.
honest,
Is
there
that
are
right? Am I,
places,
yeah,
yeah,
right,
oh,
right, yeah.
100%.
Okay.
You
Wow,
nailed
that's
it.
a lot. That's
Yeah.
awesome.
So with all that, even there is a place for surface detention, retention. There's a place for
Oh,
it. It's
sure.
not always where you are forcing it. And when
Right.
you're forcing things, they don't do many times what you think they should be doing. And if you have more options, more tools available to you, everything gets better because you're now going to start to apply the appropriate tool in the appropriate location. And that really is responsible spending in the
Yeah,
end.
I mean,
And
as you
there's
already
nothing
said
else
it,
you can improve from there.
yeah, you already said it. The better the model, the better the design, right? And then the better the outcome. Let's dive in a little bit more. I mean, you talked about the credit trading. I don't know anything about that, and I'm assuming there's some of our awesome stormwater nerds on this call probably would care to learn more, or if we could go into that a little deeper if you want to.
Yeah, that's kind of the emerging thing. I mean, one thing
Okay.
about data is much like the stock market, if there's a Bloomberg for stormwater information available, that's what P4 is going to try to be. We are the
Right.
source of
Right.
information on stormwater performance and operations and maintenance. And if you extend that into what people are currently doing, the spending is a big problem right now, right? A lot of municipalities, entities are forced to comply with rules that have a good goal. I mean, clean surface water is what we all want to have. It has a variety of benefits for us for long periods of time. So once you want to have that goal in place, the next thing is how do you, of course, get there, and how do you get there with an economical path? The concept of credit trading is if, let's say you're looking at volume credit trading, if there is a development going on in an urban environment and the stormwater runoff that that development is creating is excessive for what the design can afford for that development. You may be building underground tanks, you may be building surface ponds, you may be conveying it away to other locations. Let's just say that the cost to do the stormwater management is excessive. Well, we would love to have a responsible development created. Everybody gets an economic bang for the buck there. But in order to do that, let's say that there's a property in the same watershed, 3 addresses down or next door. If that property has excess stormwater volume capture, then they can sell those credits to the new development and make their stormwater management plan more feasible economically. So that's on volume. So if they're capturing more water and they only need to capture a certain amount for their own compliance, then they can sell excess elsewhere. But what you need for the basis of that, in my opinion, is not a model. You need measured data. Because I know statistics well enough to know you can make statistics do almost anything you want them to do. You just play
Right.
with the math and nobody ever questions you. Well, data is the way that you kind of make the common ground. If you
Right.
each have data and you know what's available, and as a purchaser of that credit, you know it's going to be there when you need it, data's that path. So they're doing that with volume in areas that are in urban environments where development wants to continue. On the other coin, there's also pollution credit trading.
Okay.
So if I'm in a community, in my neighboring communities that are easy for me to come up with, Shorewood is right on Lake Michigan in Milwaukee, Wisconsin, and just to the west is Glendale. They both are connected to the Milwaukee River, and the Milwaukee River is a challenged body of water, and we're trying to limit pollutant discharge into the Milwaukee River. Well, let's say that Shorewood has a little more coin than Glendale. Glendale has the same mandates from the EPA to provide clean surface water and not pollute the Milwaukee River. Well, maybe Shorewood's got a little extra credit that they can sell to Glendale. They're both tapped and connected to the same body of water. They're both within the watershed that is appropriate. So if somebody has extra pollution credits, then they can trade those with those that need them. And then you create a small economy of data to allow people to faster and more, I guess you would say more quickly, get clean water as the goal. Because right now, a lot of people are faced with enormous expenses. We have a small city, Whitefish Bay. Their recommendation was $12 million of spending for clean water tapping into the Milwaukee River. And that's something like $1,700 a resident in the
Oh
city.
wow, it's small. Okay.
So
Yeah.
it's excessive. So if they can get
Mhm.
credits for pollutant capture elsewhere, and there is a reliable measured source of that, then there's a little economy that can grow, and everybody can help everybody get the clean water that we need and do it in a fiscally responsible way.
Gotcha. But now, I mean, maybe it's my ignorance and not totally understanding. It's like, so if you're trading credits back and forth, though, but that doesn't lessen the responsibility of the entity that needs the credits, though, right? I mean, it's not kind of is that letting them off the hook per se, or
No,
am
because
I
they're
not get?
financial, well, they can build their own. So in
Yeah.
other words, they have the same mandate
Right.
to not pollute a surface
Right.
body of water in the pollution credit realm.
Right.
So they are going to be fiscally tied to this neighboring community. They're going to be paying for those credits.
Gotcha.
So whether they decide to build their own or purchase the effective credit, they can do that. Now, that other entity has to make sure that that pollutant removal is present and will always be present for the
Sure.
duration of that purchasing arrangement. So there's really nobody pushing off the problem to somebody else. Somebody else, in effect, is taking some responsibility for
For the
removing that, but they're
I got
being
you.
financially compensated for doing that,
I got you. I got you. So it's not
if
like
that
a
makes
free.
sense.
It's not a free pass.
No, no.
It's just an equal. It's just kind of equaling it out. Like if I'm overdoing it and you're struggling to afford to do it, but it's all the same body of water, and we're coming to the same conclusion of water quality, because it's just economically feasible, then we can share in that responsibility. But since I can't build it out and you built it out and you're over delivering because you've got whatever it is, paved drain or whatever other device that's over delivering, and then we know it's over delivering because of the data that you're providing, then we're all good. And I just need to pay for that offset. And but the water itself is still getting a better level of compliance than this person. Just like we're just recognizing places where we can assist each other against the same
Yeah.
body of water.
And of course, you
Right.
can't assume that you're going to get more um, stormwater in
Right.
this other watershed necessarily. It's not like you can
Right.
make things up and say, "Oh,
Right.
I'm going
Right.
to
Right.
capture this much more next year."
Right.
No,
Right.
you've gone into it knowing that you've got more capacity than you need, and
Gotcha.
the data, both environmental data with the rainfall and measured data within the system, tells you that that's happening. And once you can demonstrate that, you can afford others an opportunity to tap into that too. And I think from a savvy development point of view, if I'm doing a large, call it industrial distribution park, where you may have four or five 200,000 square foot plus buildings with parking and things like that, if I'm the first one in that industrial park, maybe I'm going to build that excess capacity. And I'm going to show that I have this stuff available so that the follow-ons that come into the business park realize that some of my stormwater management can be accomplished by the person that thought about it ahead of time, and they're going to now recoup some costs, not only for
Hmm.
what they put into the ground, but potentially a little
Excuse me.
bit to
Yep.
add to their reduction in mortgage. There's a lot
Right.
of options once the data's there and you start to understand how it plays with one another and how everybody interacts with one another. And that's what the data really affords in the end, is how this stuff is really performing.
And is this going on already in a lot of areas? Again, I apologize for my ignorance. Where is this happening? Is
Well,
this?
the volume credit trading is in the bigger urban environments. So Washington, D.C. area, the metro Washington area has
Mhm.
a volume credit trading program that is up and running and has been for, I think, almost 10 years now. City of Chicago has a large credit trading arena for volume available as well. And all states now, because of the EPA Clean Water Act that has been kind of growing into surface water, clean
Mhm.
water, that is, that pollutant credit trading is established in many of the states and their legislative mechanisms now. Not a lot of people are trying it. It's very new, but there's one example in the National Stormwater Trust that I'm familiar with in Florida that is doing nutrient credit trading because they've got a lot of large ponds that they understand the volume and where it is all the time, and they're beginning the process of selling credits to the surrounding community based upon the established volume they know they have in the ponds that they've developed.
Cool. So if we step back again, so we were kind of looking at the numbers, and we looked at some examples, and then now we've looked at some of the I don't know how you call it, the business side of it, if you will. Like if we step back and you just like, what's your vision as far as like where's this all going, right? Like not stormwater. You can be general in stormwater or specifically in what P4 is doing, just with this big data. You mentioned regional and national. What's the what's the end game if you were to have like, what's that look like to you?
Yeah, then I'll step through it a little bit. We have a larger effort going on in Peoria, Illinois now, and that is a permeable pavement instrumentation set up with paved drain. And in the end, they're probably going to have upwards of 16 or 17 pieces of stormwater infrastructure in Peoria specifically instrumented. So, from the city of Peoria's point of view, they will understand where and how much stormwater is coming to each one of those devices. So, number one, any consultant or consulting engineering entity, and even the city of Peoria, if they do their own design work, will have better understanding about how their watershed behaves based upon what they know is being received in these pieces of stormwater infrastructure that they have in their city. And that's really good for Peoria because they get better design. And when a consultant comes in, I envision somebody coming along and saying, "Hey, Peoria, where's your data?" It's much like a GIS map. Right
Yeah.
now, they come in and they say, "Hey, where's your GIS layer?" And then
Yeah.
you get that, and it's the
Yeah.
GIS layer for the infrastructure, the roads, the properties, etc. And you go in and you examine that. I see in the future, someone will say, "Where's your infrastructure data?" And then you
Yeah.
pull that layer into a computer somewhere, and then you go about doing your design in the most appropriate way given the data that you have. And then as you design and add to that system, maybe you're going to instrument more of the entities you put in, then your model gets better. And there will eventually be a GIS layer that is data. And we're setting ourselves up to be that as well. So we're a dashboard and a data layer where you basically just extract and layer into your Esri system a layer of data that is for the stormwater infrastructure. Now that's important for the community and important for the consultants because the design that you get is going to be better. It will likely be cheaper, but more importantly, everybody will understand what's going on, and with GIS layers and data, you can actually show the general public what's going on. So you can
Hey,
have
how about that?
worldwide access
That'd be
to when
great.
somebody says, "How much stormwater did you capture last year?" There's a GIS layer that says, "Well, within this community, there's 19 pieces of stormwater infrastructure. Each one of those 19 captured this, 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 and this. Your tax dollars went directly to that. It didn't capture anything before because we didn't know, we didn't measure it. Now we know, and here's what it is." And then as you grow out from the municipality to the state level, and then out from the state level to the regional level, and then from the regional level to the national level, you now have a whole lot of more explicit and defined understanding of stormwater. And maybe you have a consultant in Iowa that wants to do work in Illinois, and they want a data layer so that they can understand the watershed really as well as somebody in Illinois. Now you have competition growing, and you have
Right.
more economical design occurring because you have more people participating in it. And in the end, it becomes an EPA compliance tool. Instead of having people fill out forms and submitting things that nobody ever looks at, you simply drop into a database, download the information, synthesize it, and display it on a national map. And everybody knows. It's
Yep.
transparency in the end as well.
Yeah, now you're talking. I love it. I love it. There's so much narrative still in this compliance effort that we do. So much, if we could just get it consistent with the data, then you could see your anomalies. People could, not that I'm, not that I want people to get audited or have to go through that, but it's so random sometimes it seems like.
Yeah.
But if you've got big data, you can just look at, anytime you've got data, you can just look at anomalies and go, "What? That's not right. What's going on there? We need to go.
Yep.
We need to put some boots on the ground." And it's not even almost from an auditing standpoint at that point that they're in trouble. It's just like something's not right compared to, we just need to go check it out. Um, Man,
Yeah,
this
that's
has
a great
been,
point.
this is amazing. And real quick, and I don't know if we touched on it too, and I don't like people to have to necessarily draw conclusions on their own. Everything we've talked about in this data, there's not additional manpower where you're going out and you're manually pulling this data. This data is in real time, right? Like this data is being sent to to a dashboard, to a computer, right? You can just pull up the information
Yeah.
the way
And
all
what
of
we
it,
did is,
right?
yeah, at least as far as our little bid for P4, so to speak, the way that we designed our sensor systems is that we started out assuming that it would need to be post construction. So
Okay.
everything is installed after you've already got a piece of infrastructure in place. And we developed all the methods to do that. But yeah, exactly right. For example, in a permeable pavement installation, we will pull a couple of blocks out of the surface of the pavement. We will drive in a sensor shell into the ground. It takes about 30 or 40 seconds to drive in the shell. And then we throw in a sensor. Our blocks have computers inside of them. We throw those blocks back in the pavement surface. And the minute you turn that block on, data is being transmitted. So from the time that you arrive at the site to leave, it's probably 25 minutes and you're starting to gather data from below the surface of permeable pavement. Some other
Awesome.
installations are a little more involved. It's all cell based, which sometimes it's good, sometimes it's bad. We have cell phone issues. We always notice those. Um, but it's Wi-Fi based as well if you have a network nearby and you can connect to it. We've talked about LoRa, which is long range WAN
Yep.
networks, but
Yep.
you need to have that system in place in the city that you're at. But all of our hardware, we can accommodate really anything. But we're cell transmission, and literally the minute you turn it on, you're getting data, and then you view that in a variety of ways. Usually on a desktop, you can download the data and the form that we help curate. We want to make sure that the data stream and what you're seeing is what you want to see, as well as in the format that you need to see it and the reliability that you need to have it. And once that's there, you're basically viewing within an hour of install, and then it's just sit and wait. It's almost like fishing.
It's amazing. I just, again, I'm on the cheap seats over here in the industry, but I don't see how, as we wrap up, well, before I even give those my final thoughts, like, if you want to get in touch with Dr. Foley, all of his contact information is going to be in the show notes. Dr. Foley, is there a way in which you would prefer to be contacted, your email address, or do you want to?
Email is probably the most reliable. I'm always checking that. A
Okay.
LinkedIn direct message is also great too. I'm plugged into those on occasion, but not as
Hey,
often as frequently
hey.
as
All
the
right.
email. I'm getting
All
better.
right.
We
There
have
you
an
go. There you
Instagram
go.
page. I can get you in touch with a lot of things.
So, well, we'll put all of his stuff, all of his contact information and the website and all that'll be in the show notes. But it sounds like if you want to ask Dr. Foley some specific questions about your needs, or just follow up and just want to geek out with him, I'm sure he's happy to geek out on all things data. Just shoot him an email. But as back to my final thoughts is like I just don't know. Again, and I'm not having to do this on a daily basis, but I just don't know how you go out there and you spend tens of thousands, hundreds of thousands, millions of dollars of taxpayers' money and you don't know if it's going to work. I mean, and we've been doing it for years, and I don't mean to get on a soapbox or just put my thumb in anybody's eye right now, but I mean, if there's a way to spend any additional dollars or work it into my budget to where I can look somebody in the eye and say, hey, this is what this is for, and this is what it does, and I know it does it because here's the data. No brainer to me. No, in my humble opinion. So, as we wrap up, any final thoughts that you'd like to
No,
share with everybody?
Ty, I concur with you 100%. It's a relatively small amount of money for knowledge that is incredibly important. And a lot of times people like to operate without the transparency because then there's really no questions that can get raised. But the transparency is important because it benefits everybody, the designers, the constructors, the municipalities, and the taxpayers. Everybody will get a better product when you know how well it performs, or if it's not performing.
Or yeah, I mean, you gotta. I don't know. At some point, the transparency's got to become paramount, and you got to be willing to take it on the chin, and and it goes back to everything. It's a big circle, right? Like so. If the data goes in, you got better data, then you got a better model, then you can design a better, mousetrap, if you will, a better stormwater quality train, better whatever program, and then there is no fear, there is no concern. It's just literally here's what it is, and here's the data that proves it, and we knew it was going to work because it's working everywhere else because the data is there. I mean, it's just not. We get away from the theory. And even in the testing world, there's just too many controls in a testing environment that are just not out in the real world. You just can't create a real world. We don't have a movie style, place where we could just create an environment and test it like it's real, And so here it is. Here's the real data, and I love it. Dr. Foley, I thank you so much for taking your time and coming on the podcast today. I really appreciate you sharing your thoughts with us today.
Well, thank you, Ty, and Stormwater World crew. It was fun.
Appreciate it. Thank you for listening to this episode of the Stormwater World podcast. Do you have something you'd like to discuss? Do you have an opposing opinion regarding something you heard during this episode? Let's talk about it. Click on the link in the show notes to sign up for a future episode. I'd love to visit with you about what's happening and how you see things unfolding in your stormwater world.